The sun burned hot against the red desert sand of Kepler 442b as Jake Morrison stepped off the transport shuttle. The heat hit him like a wall, making his academy uniform stick to his back instantly. Around him, other cadets from different worlds were already complaining about the harsh conditions, the various breathing apparatus and cooling systems, working overtime to keep them comfortable. Jake wiped the sweat from his forehead and looked around at his assigned squad. 3 alien beings stood nearby, each one more different from him than the last. The first was Zixtal, a creature that looked like walking crystal formations with light flowing through its transparent body. Every time it moved, small chimes rang out from its crystalline structure. The second was Vorth, an insectoid being with 6 arms and compound eyes that reflected the desert sun like mirrors. Its chitinous shell was a deep green color that seemed to shift and change as it moved. The third was Kella, a being made of gas that lived inside a mechanical suit that hummed with energy. Through the suit's transparent visor, Jake could see swirling clouds of blue and purple gas that formed its true body. "Welcome to survival training," announced Instructor Rawlings, a tall woman with scars on her arms and a voice that carried across the desert wind. "You have 6 hours to build a shelter that can protect you from temperature changes, sandstorms, and the various dangers this planet offers. You will work in your assigned squads of 4. The shelter must be big enough for all team members and strong enough to last through the night." Jake looked at his 3 teammates who were already opening their equipment packs. Each alien had brought what looked like a small warehouse worth of advanced technology. Zixtal pulled out a device that hummed with power and had a screen displaying complex diagrams. Vorth produced several metallic components that seemed to unfold and reshape themselves. Kella's suit dispensed various tools and gadgets that floated around it like a mechanical cloud. "What did you bring, Jake Morrison?" asked Zixtal, its voice sounding like wind chimes in a breeze. The crystal being looked at Jake's small pack with what might have been concern. Jake opened his standard issue survival pack and laid out its contents on the sand. Water purification tablets, basic food rations, a simple knife, rope, and a small first aid kit. Compared to his teammates' advanced equipment, his supplies looked primitive and inadequate. "That is all you have?" Vorth clicked its mandibles together in what Jake guessed was surprise. "Where are your molecular assemblers? Your climate control systems? Your energy generators?" "This is what humans get," Jake said with a shrug. "It's all I need." Kella's gaseous form swirled faster inside its suit, creating small storms of color. "We can share our technology with you, Jake Morrison. It would not be fair for you to fail because of inadequate equipment." "Thanks, but I'm good," Jake replied, standing up and brushing sand from his knees. While his teammates continued unpacking their sophisticated gear, Jake walked away from the group to explore the area. The desert stretched endlessly in all directions, broken only by rocky outcroppings and the occasional dried riverbed. The sun was merciless, and Jake could feel his skin starting to burn despite the sunscreen he had applied. He noticed how the wind patterns shifted across the landscape, carrying sand and dust in specific directions. Most importantly, he saw something his teammates had missed in their excitement over their technology. About 200 meters away, there was a dried riverbed that curved around a small hill. The sand there was different, darker, and more compact. Jake walked over to investigate, kneeling down and digging with his hands. The soil felt different here, clay-like and sticky when he added a little water from his canteen. "Perfect," he muttered to himself, rolling a small ball of the clay between his palms. It held together well, not too wet and not too dry. This was exactly what he needed. Meanwhile, his teammates had spread their equipment across a large area and were studying holographic blueprints that appeared in the air above their devices. Zixtal's crystal structure pulsed with different colors as it processed information, while Vorth's compound eyes moved independently to track multiple data streams. Kella's suit produced a 3-dimensional map of the area, complete with wind patterns and temperature readings. The optimal shelter design would be a geodesic dome, Zixtal announced, its chimes ringing with confidence. My molecular assembler can create the necessary support structures from the silicon in the sand. Negative, Vorth interjected, its 6 arms moving in complex patterns. The insectoid hive design is superior for desert conditions. My habitat pod can be deployed and expanded to accommodate all 4 of us. Both of your approaches are inefficient, Kella's mechanical voice buzzed through its suit's speakers. Energy shields provide the most reliable protection. My generators can maintain a climate-controlled environment indefinitely. Jake returned to find his teammates deep in technical discussions about load-bearing calculations and energy efficiency ratings. They had been debating for almost an hour while Jake had been exploring, and they were no closer to actually building anything. "What did you find over there?" Vorth asked, noticing Jake's return. "Good clay," Jake said simply. "The kind that's been used for building for thousands of years on Earth." Zixtal S crystal formations shifted to a pattern that suggested confusion. Clay is a primitive building material. Our technology can create structures far superior to anything made from natural materials. "Maybe," Jake said, sitting down in the sand. "But clay doesn't need power sources or complex calibration. It doesn't malfunction when it gets too hot. Or too cold, and it's right here, free for the taking." The alien cadets exchanged glances, or what passed for glances, among their various sensory organs. To them, Jake's approach seemed impossibly backward. They had spent years learning to use advanced technology, and here was this human talking about building with mud like some primitive ancestor. "We appreciate your input, Jake Morrison," Kella said diplomatically, "but we believe our technological solutions will prove more effective. You are welcome to assist us in implementing our design." Jake nodded and settled back to watch his teammates work. The sun was getting higher, and they had already lost precious time to planning and debate. He could see storm clouds forming on the horizon, which meant they might have even less time than the instructor had given them. As the alien cadets began activating their devices, Jake closed his eyes and felt the desert wind on his face. Somewhere in the distance, he could hear the sound of other squads working on their shelters, the whir of machinery and the beep of electronic devices. But Jake was listening for something else, something his teammates' advanced sensors couldn't detect. He was listening to the desert itself, learning its rhythms and understanding its challenges. And when the time came, he would be ready. The alien cadets began their construction with confidence that quickly turned to frustration. Zixtal activated its molecular assembler, and the device hummed to life with a series of electronic beeps. The crystal being's body pulsed with bright colors as it interfaced with the machine, feeding it instructions for creating shelter components from the desert sand. "Beginning silicon extraction and molecular restructuring," Zixtal announced, its chimes ringing with satisfaction. But within minutes, the assembler started making strange grinding noises. The screen flickered with error messages, and the device began overheating in the desert sun. "What is the problem?" Vorth asked, its compound eyes focusing on the malfunctioning equipment. "The sand contains too many mineral impurities," Zixtal replied, its crystal structure dimming with worry. "The assembler cannot process materials with this level of contamination. The sensors are unable to distinguish between useful silicon and unwanted elements." Meanwhile, Vorth had deployed its habitat pod, a sleek metallic cylinder that was supposed to expand into a full shelter. The insectoid being pressed a series of buttons on the pod's control panel, and mechanical arms began extending from its sides. But as the pod tried to unfold, sand grains got caught in its joints and gears. "Negative function detected," Vorth clicked in frustration. "Sand particles are interfering with the expansion mechanism. The pod requires a clean environment to deploy properly." Kella was having similar problems with its energy shield generators. The mechanical suit had produced several disc-shaped devices that were meant to create a protective barrier around the team. But the generators kept overheating in the intense desert heat, and their cooling systems couldn't keep up with the extreme temperature. "Generator efficiency dropping to 60%. Keller reported, its gaseous form swirling anxiously inside the suit. "Thermal regulation systems are inadequate for this environment. Power consumption is exceeding projected parameters. Jake watched his teammates struggle with their advanced technology while he walked back to the dried riverbed. The clay he had found earlier was still there, waiting for him like an old friend. He knelt down and began digging with his hands. Scooping out handfuls of the dark, rich soil, the clay felt perfect between his fingers, cool and smooth despite the heat above. Jake had learned about working with clay during his childhood on Earth, helping his grandfather build a garden wall behind their house. His hands remembered the feel of good clay, the way it should respond to pressure and moisture. "What are you doing, Jake Morrison?" Zixtel asked, walking over to observe the human's strange behavior. Its crystal structure tilted in a way that suggested curiosity mixed with concern. "Testing the clay," Jake replied, rolling a small ball between his palms. He pressed it flat, then rolled it again, feeling how it held together without cracking. "This is perfect building material. It has just the right amount of moisture, and the texture is exactly what I need." "But that is primitive methodology," Zixtel said, its chimes ringing with confusion. "How can natural materials compare to engineered components? Our technology can create structures with precise specifications and optimal performance characteristics." Jake smiled and continued working the clay. "Humans have been building with mud and clay for thousands of years. Long before we had any advanced technology, we were creating homes, walls, and entire cities using nothing but our hands and natural materials." He demonstrated by adding a small amount of water from his canteen to the clay, mixing it with his fingers until it reached the perfect consistency. "See how it binds together? The clay particles naturally stick to each other when they have the right amount of moisture. No power source required, no complex calibration needed." Vorth approached with its habitat pod still stuck halfway between folded and deployed. "But how do you know the structural integrity will be adequate? How do you calculate load-bearing capacity without sensors and measurements?" "Experience," Jake said simply. "Human hands can feel things that your sensors can't detect. I can tell by touch whether the clay is too wet or too dry, whether it will hold together or fall apart. My fingers can sense temperature changes, texture, variations, and moisture levels better than any machine." Kella's suit approached, its generator still overheating and sparking occasionally. "This seems highly inefficient. Our technology can process thousands of variables simultaneously and optimize for multiple performance criteria." "Maybe," Jake said, standing up and wiping clay from his hands. "But your technology keeps breaking down in conditions it wasn't designed for. This clay has been here for thousands of years, through countless storms and temperature changes. It's already adapted to this environment." The alien cadets watched as Jake gathered more clay, building a small pile near the riverbed. He explained that the curved bank of the dried river would provide natural wind protection, while the slight elevation would help with drainage if it rained. These were things that didn't show up on their sensors or computer models, but Jake could see them just by observing the land. "The desert teaches you what you need to know," Jake continued, kneeling down to examine the clay more closely. "You just have to listen to it instead of fighting against it." Zixtel's molecular assembler chose that moment to emit a loud alarm and shut down completely. The crystal being's structure flashed red with alarm as diagnostic messages scrolled across the device's screen. "Critical system failure," Zixtel announced. "The assembler has overheated and cannot continue operation. Estimated repair time exceeds exercise duration." Vorth's habitat pod was making grinding noises as sand continued to jam its mechanisms. Despite the insectoid's best efforts, the pod remained stuck in its half-deployed state, useless as a shelter. "Sand infiltration has compromised primary systems," Vorth reported. "Manual extraction of particles would require disassembly of the entire unit." Kella's energy shield generators were now smoking, their cooling systems completely overwhelmed by the desert heat. The mechanical suit's internal temperature warnings were flashing continuously as the equipment continued to malfunction. "Generator array is non-functional," Kella said, its gaseous form appearing agitated. "Power systems are unable to maintain operation in current environmental conditions." Jake looked at his teammates with sympathy. Their advanced technology, so impressive in controlled laboratory conditions, was failing completely in the real world. The desert was too hot, too sandy, and too unpredictable for their precise instruments and delicate mechanisms. "Want to try building with clay?" Jake offered. "I can show you how it works." The alien cadets looked at each other, then at their broken and malfunctioning equipment. Storm clouds were gathering on the horizon, and time was running out. They were beginning to realize that sometimes the oldest solutions were the most reliable ones. Jake began building his shelter while his alien teammates watched their expensive equipment fail around them. He started by gathering small stones from the dried riverbed, selecting each one carefully. His hands moved with practiced ease, feeling the weight and texture of each stone before deciding where to place it. "First, you need a good foundation," Jake explained as he arranged the stones in a circle about 8 feet across. "These rocks will keep the clay walls from sitting directly on the sand. Water can't soak up through stone as easily as it can through sand." Zixtel moved closer, its crystal structure pulsing with curiosity. "How do you determine the optimal diameter without calculations? What mathematical formula guides your stone selection process?" Jake smiled as he pressed a particularly flat stone into the sand. "No math needed. I just think about how much space 4 people need to sit comfortably, then add a little extra. As for the stones, I pick ones that feel right in my hands. Flat ones for the base, rounder ones for gaps." He demonstrated by lifting 2 stones, weighing them in his palms. "This one is too light, probably hollow inside. It might crack under pressure. This one feels solid, dense. It will hold weight well." Jake tossed the lighter stone aside and placed the heavier one in his foundation ring. Vorth watched with its compound eyes as Jake began mixing clay with water from his canteen. The human's hands moved through the mixture like they were dancing, feeling for the right consistency. "Your tactile sensors are more sensitive than our instruments?" the insectoid asked. "Human hands have thousands of nerve endings," Jake replied, kneading the clay between his fingers. "I can feel temperature changes, moisture levels, texture variations that your machines might miss. Plus, I learned this from my grandfather when I was young. He taught me that clay talks to you if you listen with your hands." Jake scooped up a handful of the mixed clay and began shaping it into a brick-like form. His fingers smoothed the surface, checking for air bubbles or weak spots. "See how it holds together? Not too wet, not too dry?" If it was too wet, it would slump and lose its shape. Too dry, and it would crack and fall apart. Kella's mechanical suit approached, its damaged generators still smoking slightly. "This process appears highly inefficient. Our technology could have completed structural analysis and begun construction within minutes." "Maybe," Jake said carefully, placing his first clay brick on the stone foundation. "But your technology is broken, and my clay is working perfectly." He smoothed the brick into place, ensuring it bonded well with the stones below. As Jake continued building, his movements became more fluid and confident. Each handful of clay was shaped and placed with precision, but not the rigid precision of a machine. Instead, Jake adapted to the natural variations in the material, adjusting his technique based on what he felt through his fingertips. "The secret is working with the clay, not against it," Jake explained as he added another layer to his growing wall. "Every batch is a little different. Some is stickier, some is drier. You have to feel what each handful needs and adjust accordingly." Vorth was fascinated by Jake's technique. "You are using your entire body as a sensor array. Your hands detect material properties, your eyes judge structural alignment. Your muscles provide force feedback for optimal compression." "Never thought about it that way," Jake said, pausing to wipe sweat from his forehead. "I just do what feels right. Humans have been building like this for thousands of years. The knowledge gets passed down from person to person, generation to generation." The alien cadets watched in amazement as Jake's shelter began to take shape. The walls curved inward slightly, creating a dome-like structure that seemed to grow naturally from the ground. Jake explained that the curved shape was stronger than straight walls because it distributed weight evenly in all directions. Ancient humans discovered that domes could support much more weight than flat roofs. Jake said, shaping another clay brick with his hands. The curve transfers the load down to the foundation instead of letting it accumulate at weak points. Zixtolsa. Crystal's structure brightened with understanding. The mathematical principles are sound. A dome distributes stress vectors optimally across the entire surface area. But how do you maintain proper curvature without surveying instruments? Jake held up his hands, fingers spread wide. These are my instruments. I can feel when the curve is right, when each brick is placed at the correct angle. My eyes can judge the shape, my hands can feel the balance. As the afternoon wore on, Jake's shelter continued to rise. He created a small entrance tunnel that curved slightly, explaining that this would prevent sand from blowing directly into the shelter during storms. Near the top of the dome, he left small holes for ventilation, carefully positioned to allow airflow without letting in rain or sand. The entrance faces away from the prevailing wind, Jake noted, gesturing toward the storm clouds gathering on the horizon. And the tunnel shape creates a barrier that blocks most of the sand while still allowing easy access. Kella's gaseous form swirled with interest inside its damaged suit. You determined wind patterns through observation alone? Our meteorological sensors would have required extensive calibration to achieve similar accuracy. I watched the sand blow around for a while, Jake replied simply. You can see which direction the wind comes from by looking at how the dunes are shaped, how the dust moves. The desert tells you everything you need to know. The alien cadets began to realize that Jake wasn't just building a shelter, he was creating something that worked in harmony with the environment. His clay walls would breathe with temperature changes, expanding and contracting naturally. The thick walls would provide insulation against both heat and cold. The curved shape would deflect wind and distribute structural loads efficiently. It is beautiful, Zixtel said, its chimes ringing with genuine admiration. Your shelter appears to be growing from the earth itself as if it belongs here. Jake stepped back to examine his work, his hands still covered in clay. The shelter was nearly complete, its smooth walls rising from the stone foundation like a natural formation. It looked ancient and permanent, as if it had been there for centuries rather than hours. That's the idea, Jake said, wiping his hands on his pants. Good building works with nature, not against it. This shelter will keep us cool during the day and warm at night. It will stand up to wind and sand because it's made from the same materials as the desert around it. Thunder rumbled in the distance, and the storm clouds were moving closer. Jake's alien teammates looked at their broken equipment and then at the solid, reliable shelter that the human had built with nothing but his hands and natural materials. They were beginning to understand that sometimes the most advanced technology was the simplest solution. The storm hit without warning, 3 hours ahead of schedule. Dark clouds that had been gathering slowly on the horizon suddenly raced across the sky, driven by powerful winds that made the desert sand dance and swirl. Lightning flashed in the distance, followed by the deep rumble of thunder that shook the ground beneath their feet. Emergency weather alert, Kella announced, its mechanical suits remaining sensors detecting the approaching danger. Severe sandstorm approaching. Wind speeds exceeding safe parameters, electromagnetic interference levels critical. The alien cadets looked around desperately at their broken equipment. Zixtol's molecular assembler sat silent and dead, its screen dark and lifeless. Vorth's habitat pod remained stuck in its half-deployed state, offering no protection from the elements. Kella's energy shield generators were still smoking from their earlier overheating, completely useless against the approaching storm. We need immediate shelter, Vorth clicked urgently, its compound eyes reflecting the flashing lightning. Our equipment cannot provide adequate protection in current conditions. Jake had just finished sealing the last ventilation hole in his mud shelter when the first gusts of wind hit. Sand began flying through the air like tiny bullets, stinging exposed skin and making it difficult to see more than a few feet ahead. The temperature was dropping rapidly as the storm clouds blocked the sun. "Everyone inside?" Jake called out, gesturing toward the entrance tunnel of his clay dome. "Move quickly but stay low. The tunnel will protect you from the wind." Zik still hesitated, its crystal structure flickering uncertainly. Will the primitive construction withstand the storm conditions? Our sensors detected wind speeds that could exceed structural limits. Trust me, Jake said, grabbing his pack and heading for the shelter entrance. This thing has been built to last. The alien cadets had no choice but to follow. As the storm intensified, they abandoned their expensive equipment and crawled through Jake's entrance tunnel into the clay dome. The contrast was immediate and startling. Outside, the wind howled and sand whipped through the air with violent force. Inside Jake's shelter, there was calm and quiet. The curved walls of the dome deflected the wind perfectly, creating a peaceful haven in the middle of the storm. The thick clay provided excellent insulation, keeping the interior comfortable despite the temperature changes outside. Most importantly, the natural materials were completely unaffected by the electromagnetic interference that was disrupting electronic equipment across the desert. This is remarkable, Zixtel said, its crystal structure pulsing with amazement. The acoustic dampening properties are superior to our manufactured materials. The electromagnetic shielding is perfect. Vorth tested the walls with its 6 arms, feeling the solid construction. The structural integrity exceeds all expectations. How did you calculate the load-bearing requirements without engineering software? Jake settled down on the floor, which he had covered with a layer of soft sand. I didn't calculate anything. I just built it the way humans have always built shelters. Strong enough to do the job, flexible enough to adapt to changing conditions. Outside, the storm raged with increasing fury. Lightning struck nearby, sending electromagnetic pulses through the air that would have fried any electronic equipment. The wind howled at speeds that would have torn apart conventional shelters. Sand and debris flew through the air with enough force to strip paint from metal surfaces. Inside the clay dome, the 4 cadets sat in comfortable safety. The walls seemed to breathe with the storm, expanding and contracting slightly as the temperature and pressure changed. The clay naturally regulated humidity, absorbing moisture when the air was too wet and releasing it when conditions became too dry. I have never experienced anything like this, Kala said, its gaseous form swirling more peacefully inside its suit. The shelter feels alive as if it is part of the planet itself. Jake nodded, running his hand along the smooth wall beside him. That's because it is part of the planet. The clay came from this desert, the stones from this riverbed. The shelter belongs here in a way that manufactured materials never could. As the storm continued, Jake shared stories about human architecture throughout history. He told them about the ancient Pueblo dwellings in the American Southwest, built from adobe clay and still standing after hundreds of years. He described the traditional houses of Africa, constructed from mud and thatch, perfectly adapted to their local climates. Humans have always had to work with what was available, Jake explained. We couldn't just order materials from across the galaxy. We had to learn to use what the Earth provided, to work with natural systems instead of fighting against them. Zixtel's crystal structure dimmed thoughtfully. Your species developed architecture through necessity and adaptation. Each generation refined techniques based on direct experience with environmental challenges. Exactly, Jake said. And that knowledge gets passed down through hands-on learning. You can't learn to work with clay by reading about it or watching videos. You have to feel it, work with it, understand how it behaves in different conditions. The storm reached its peak intensity, with winds that would have destroyed any conventional shelter. But Jake's mud dome stood firm, its curved walls shedding the wind like water. The entrance tunnel prevented sand from blowing inside, while the ventilation holes near the top allowed fresh air to circulate without admitting the storm. Arth was amazed by the engineering principles at work. The aerodynamic design is optimal for wind resistance. The thermal mass of the clay provides natural temperature regulation. The structural geometry distributes stress efficiently across the entire surface. Maybe, Jake said with a smile. But I wasn't thinking about aerodynamics or thermal mass. I was just building a shelter that would keep us safe and comfortable. Sometimes the best engineering happens when you're not trying to be clever. As the hours passed, the alien cadets began to understand something profound about human ingenuity. Jake hadn't built his shelter by following complex calculations or advanced theories. He had built it by combining thousands of years of human experience with his own intuitive understanding of materials and environment. Our technology failed because it was designed for perfect conditions, Kella observed. But your shelter succeeds because it was designed for real conditions, including the unexpected ones. The storm gradually began to weaken, though it continued to rage outside their protective dome. The alien cadets had learned more about human capabilities in a few hours than they had in months of academy training. They were beginning to see that true intelligence wasn't about having the most advanced tools, but about knowing how to adapt and survive when those tools failed. Jake listened to the wind outside and judged that the worst of the storm was passing. Soon they would be able to emerge and face whatever remained of the exercise. But for now they were safe and warm in a shelter built with nothing but human hands and the wisdom of ages. The storm finally passed just as the sun began to set, leaving behind a desert transformed by wind and sand. Jake emerged first from his clay shelter, blinking in the orange light of evening. The landscape looked different now, with new dunes formed where the wind had deposited sand and rocky outcroppings scoured clean by the storm's fury. His alien teammates followed him out of the dome, their various sensory organs adjusting to the changed environment. Across the training area, other cadet squads were emerging from whatever shelters they had managed to build or find. Some looked worse for wear, their expensive equipment damaged by the unexpected storm. Well, that was exciting, Jake said, stretching his arms and looking around at the debris scattered across the desert. Pieces of broken technology lay half buried in the sand. Victims of the electromagnetic interference and brutal winds, Zixtal's crystal structure pulsed with a mixture of gratitude and amazement. Your shelter protected us completely. Without it, our survival would have been unlikely. The structural performance exceeded all theoretical parameters, Vorth added, clicking its mandibles in appreciation. The construction withstood conditions that destroyed manufactured shelters. Kella's gaseous form swirled peacefully inside its damaged suit. The human approach proved superior to our technological solutions in every measurable way. In the distance, they could see the instructors' transport vehicles approaching across the desert. Commander Hendricks and Professor Nixara would be arriving soon to evaluate the results of the survival exercise. Jake looked back at his mud shelter, still standing, solid and intact despite the storm's assault. We should clean up the area, Jake suggested, starting to gather the scattered pieces of his teammates' broken equipment. The instructors will want to see what happened here. The alien cadets helped collect their damaged devices, though most were beyond repair. Zixtal's molecular assembler had been completely fried by electromagnetic interference. Vorth's habitat pod was filled with sand and would require complete disassembly to fix. Kella's energy shield generators were melted and twisted from overheating. Total equipment loss, Vorth reported matter-of-factly. All technological systems experienced critical failure during the exercise, but we all survived, Jake pointed out. That's what really matters. The instructor vehicles pulled up in a cloud of dust, and Commander Hendricks stepped out first. She was a veteran human officer with gray streaks in her hair and the confident bearing of someone who had seen many challenging situations. Behind her came Professor Nixara, a multi-tentacled being from the Centauri system whose species was known for their analytical intelligence. "Report, cadets," Commander Hendricks said, her voice carrying easily across the desert wind. Her eyes immediately went to Jake's intact shelter, then to the scattered remains of advanced equipment around the area. Shelter construction completed. Successfully, Jake replied. All team members survived the storm without injury. Professor Nixara approached the clay dome, extending several tentacles to examine its surface. Fascinating construction methodology. The material composition appears to be indigenous clay and stone formed into an optimal geometric configuration. How did your technological solutions perform? Commander Hendricks asked the alien cadets, though she could already see the answers scattered around them. Complete system failure, Zixtel admitted, its crystal structure dimming with embarrassment. Environmental conditions exceeded equipment specifications. Old devices became non-functional within the first 2 hours. Commander Hendricks nodded, walking around Jake's shelter and examining its construction. And this was built using standard-issue human equipment. Just hands and natural materials, Jake said. The clay was perfect for building, and the stones provided a good foundation. Everything I needed was right here in the desert. Professor Nixara was taking detailed measurements of the shelter with a handheld scanner. The thermal regulation properties are remarkable. Interior temperature remained optimal throughout the storm. Structural integrity shows no signs of stress or damage. The electromagnetic shielding was perfect, Kella added. Our suit sensors detected massive interference levels that would have destroyed any electronic systems. But inside the shelter, we experienced no effects whatsoever. Commander Hendricks smiled, and Jake caught a look of pride in her eyes. The human approach to problem-solving continues to surprise our galactic partners. Tell me, Cadet Morrison, how did you know this construction method would work? My grandfather taught me when I was young, Jake replied. He said humans had been building with clay for thousands of years before we ever went to space. The knowledge doesn't disappear just because we have fancier tools now. Professor Nixara finished his examination and turned to address the group. This exercise demonstrates several important principles. Advanced technology provides superior performance under ideal conditions, but natural solutions often prove more robust when conditions become unpredictable. Zixtel's crystal structure brightened with understanding. The human approach adapted to environmental challenges instead of trying to dominate them. The shelter worked with natural forces rather than fighting against them. Exactly, Commander, Hendricks said. Cadet Morrison achieved optimal results using the simplest available methods. His solution required no external power, no complex calibration, and no specialized maintenance. Most importantly, it worked when everything else failed. Vorth was examining the shelter's entrance tunnel, marveling at its elegant simplicity. The design principles are fundamentally sound, yet implementation required no computational analysis. The human combined empirical knowledge with intuitive understanding. That's what makes humans valuable partners in the galactic community, Professor Nixara explained. Your species brings unique perspectives and capabilities that complement our technological approaches. Jake felt a warm sense of pride, not just for himself, but for all of humanity. We've always had to make do with what we had. Earth didn't give us everything we needed, so we learned to work with what was available. I guess that experience comes in handy sometimes. Commander Hendricks began recording her evaluation on a handheld device. Cadet Morrison receives top marks for innovation, adaptability, and team leadership. His solution protected all squad members and demonstrated superior performance under adverse conditions. As the instructors prepared to move on to evaluate other squads, the alien cadets gathered around Jake one final time. The experience had changed their perspective on human capabilities and the value of traditional knowledge. Will you teach us more about working with natural materials? Zixtel asked, its chimes ringing with genuine curiosity. I'd be happy to, Jake replied. Next time we have a building exercise, I'll show you how to feel whether clay is ready to work with, how to judge the right consistency just by touch. Vorth clicked its mandibles eagerly. We would benefit greatly from learning human techniques. Our technology failed when we needed it most, but your methods proved completely reliable. The most important lesson, Kella observed, is that wisdom often comes from understanding natural systems rather than trying to replace them with artificial ones. As they packed up their remaining gear and prepared to return to the academy, Jake took one last look at his mud shelter. It would probably stand there for years, weathering future storms and serving as a testament to the enduring value of human ingenuity. Sometimes the oldest solutions really were the best ones, and the most advanced technology was a pair of skilled hands guided by thousands of years of human experience.